So now let's do this question. Find the current through the 10 ohm resistor. Okay, so here this is the 10 ohm resistor, which means this is the load, which means this is what you're going to remove. So after removing the 10 ohm resistor, we get, that is a resistor over here, then we have another resistor, the same, this 2 volt over here. So since I'm going to remove this 10 ohm resistor, the circuit will become like this, right? That portion will become open. There you have. Then we have another resistor over here, a 20 volt over here and 50 volt over here. Okay, so this is 6 ohm, this is 50 volt, this is 4 ohm, 2 volt, this is VTH, this is 5 ohm, this is 15 ohm, and this is 20 volt. Okay, so here you can see that since you have removed the load from here, which means this branch is open. So now you need to understand what is the name of the current through this branch. What is the name of the current through this branch? You see, if this is I1 and this is I2 and this is I3, in that case that the current through this branch is called as I2, right? So therefore, since this branch is open, which means the current through this branch is equal to 0, which means I2 is equal to 0. Okay, in other words, here since mesh 2 is open, comma, I2 is equal to 0. Okay, so therefore I2 is equal to 0. So therefore, which means that now you can apply the normal mesh analysis, and wherever you see the value I2, simply substitute that as equal to 0. Okay, this is I1 as usual. Okay, I'm not going to mark I2 because it's wrong to mark I2 because there is no current called I2 over here. That's why I'm not going to mark I2 over here, and let this be I3. Okay, so now let me apply the normal mesh analysis equation. Okay, so equation for mesh 1, equation for mesh 1. Okay, so here this I1 is touching the 6 and 4, so 6 plus 4 is 10. So we have I1 into 10 minus, and I2 is touching only this resistor, I2 into 4, right? That's it. This is equal to 50, but I2 is equal to 0, right? So therefore we have 10 I1 is equal to 50, or I1 is equal to 5 amperes there. So you have found the value of I1. Okay, so now I'm going to apply the equation for mesh 2, but it's not right to say mesh 2, right? Instead of that, we need equation, right? Say like that is equation for VTH, because this is the only mesh which has the VTH inside, right? So equation for VTH. Okay, equation for VTH. Now let me write it as a normal. If we write this equation as a normal mesh 2 equation, and then finally we will put I2 is equal to 0. Okay, so here we have minus 4I1. Okay, minus 4I1, and here you have here you have 4 plus 15, 19, right? So you have 19 I2, so plus 19 I2, and then you have minus 15 I3, and then what about the VTH? You see, if this is I2, I2 is also flowing in the clockwise direction, right? Which means it's flowing in this branch, it is flowing from left to right, which means it is flowing from a higher potential to a lower potential, which means it is plus VTH. Okay, plus VTH is equal to, now let's see the voltage source. Here, as long as when you see the voltage source, this positive terminal 2 volt is actually generating I2, right? Or is supporting the flow of current. It's supporting the flow of I2, which means it is plus 2 is equal to 2. Okay, but since I2 is but this mesh is open, right? It's considered as open, therefore I2 is equal to 0. So this term will disappear, which means we have the equation as minus 4I1 minus 15I3 plus VTH is equal to 2. There you have it. Okay, so now we already know what is the value of I1. We already found that, right? So it is 5. So which means this is minus 20. So minus 20 minus 15I3 plus VTH is equal to 2. So when you bring it over here, it will become minus 15I3 plus VTH is equal to 2 plus 20 is 22. So this is the equation. Okay, so this is one equation we found. Now I am going to write the equation for mesh 3. Okay, so equation for mesh 3, equation for mesh 3. Okay, so how this equation looks like, let me see. We have minus 15I2 plus, let's see, here I3 touches is 15, this 5, so 15 plus 5 is 20. So we have plus 20I3 is equal to, and this current is flowing into the positive terminal, right? Which means this positive terminal, this battery is not generating current. This positive terminal of the battery is not generating current. It is opposing I3. It is opposing the current. Therefore, it is minus 20. There you have. It is minus 20. So from here itself, I can say we know that I2 is equal to 0, right? So which means we have 20I3 is equal to minus 20. Or in other words, I3 is equal to minus 1 amperes. So which means I found the value of I3. I found the value of I3, which means now I can write the value of VTH, right? What is the value of VTH? That is, we have minus 15, let me see, minus 15I3 plus VTH is equal to 22, right? And here it is minus, here I3 is equal to minus 1. So we have minus 15 to minus 1 is 15. So we have 15 plus VTH is equal to 22. In other words, VTH is equal to 22 minus 15, which is 7 volt. So we found the value of VTH. VTH is equal to 7 volt. Okay. See, this, remember I forgot to say this is actually a DC circuit, right? So DC circuit, there is no capacitor or inductor. That is why everything are all real values, right? Only resistors and normal batteries. It's a DC circuit. That's why we have a simple value over here. So VTH is equal to 7 volt. Next you are going to find the ZTH. So to find ZTH, I'm going to, if I see any voltage source, I will short it, and if I see any current source, I will open it. But here in this circuit, there are only 3 voltage sources, right? Here, here, and here. So just simply short all of them. Just simply short all of them. Yeah, this is a circuit. The circuit short this 50 volt, this 2 volt, and this 20 volt. So simply short all 3 of them. So what will you get? This will become like this. And you have a 6 ohm resistor, then you have a 4 ohm resistor, we have a 6 ohm and 4 ohm, then this is also a single short, it's a single connection, this is ZTH, okay, this is A, this is B, this is ZTH, the impedance between these 2 terminals. And then we have a resistor 15 ohm and we have a 5 ohm. So we have a 15 ohm downwards and we have a 5 ohm over here, okay? And here we're going to short this 20 volt battery, so it gets short there. This is the circuit. There you have it. See, this is the circuit, okay? So now what I'm going to do is I'm going to simplify the circuit, right? Just simply simplify the circuit. So how will I simplify is, if you look at these 2 elements, right? These two elements are parallel to each other. See, because if a current is flowing through this current will get split up into 2 elements, right? It gets split up. and also, and if it gets split up also, if you look over here, this one end of the 6 ohm resistor is this junction, right? And the one end of the 4 ohm is this junction. Now look at the other end. The other end of the 6 ohm resistor is this junction, and the other end of the 4 ohm resistor is this junction, which means these two elements are parallel to each other, right? And what about these two elements over here? Well, these two elements are also parallel to each other. See, one end of the 5 ohm and one end of the 15 ohm is connected to B. Both of them are connected to terminal B, and the other end is also the same connection, right? So which means, let me now join these two elements. If these two are parallel, so you have 6 into 4 by 6 plus 4, and these two elements are also parallel, so we have 15 into 5 by 15 plus 5. So here you have 24 by 10, and here you have 75 by 20, right? Here you have 75 by 20. So which is nothing, this is 2.4, and the other one is 75 divided by 20 is equal to 3.75. so which means now I can redraw the circuit as like this. That is a single element like this, and here you have a resistor, here also you have another resistor, and these two resistors are combined, right? And this is 24 by 10 or 2.4 ohm, and whereas this one is 75 by 20, which is 3.75. so this is 3.75 ohm. Okay, this is A, this is B, and this is ZTH. So therefore now these two elements are in series, right? See, because the same current flows through both the elements, which means these two elements are in series. So therefore ZTH, or you can not solve ZTH, it's actually RTH, right? Because there is no any imaginary part, everything is real, so it's RTH, Thevenin's resistor. So RTH is equal to 24 plus 3.75, 2.4 plus 3.75, and you get is 6.15 ohm. 6.15 ohm. There you have the RTH. So you have VTH and you have RTH. Therefore, the circuit will look like this. That is, we have a single battery over here, and this is VTH, and the value of VTH is 7 volt. So therefore, VTH is equal to 7 volt. And then you have a resistor. You have a resistor over here, and this resistor is 6.15 ohm. 6.15 ohm. Okay. So now we can keep the load back to its place. What is the load? Here the question was, find the current through the 10 ohm resistor. That 10 ohm resistor you have removed at the beginning, right? So now I am going to put it back to its place. So here the question is, find the current through the 10 ohm resistor, which means this is the 10 ohm resistor right here, 10 ohm. Okay, so what you're going to do is simply find the current. What is the current? Current is I is equal to, applying mesh analysis, I into 6.15 plus 10 is equal to VTH, which is equal to 7. Or in other words, I is equal to 7 by 16.15, which is equal to, let me see, 7 divided by 16.15. 7 divided by 16.15, which is equal to 0.433 amperes. That is the answer, 0.433 amperes. Okay, therefore current through the 10 ohm resistor is equal to 0.433 amperes. Okay.